In this section, we're going to talk about the application layer. The top or seventh layer of OSI module is the application layer. The application layer provides interfaces to the software that enable it to use network services. Some of the services provided by the application layer include file transfer, electronic mail, and the web services. Applications that work at layer 7 are the ones that users interact with directly. For example, a web browser, Google Chrome, Firefox, Safari, and etc. or the other applications such as Skype, Outlook, Office are the examples of the layer 7 applications, and HTTP, Telnet, FTP, SMTP, and SNMP, and etc. are the common protocols used in the layer 7. In the client-server module, in the application layer, users can interact with client-server module again. In this module, as you know, we have clients, these guys, and we have a server. In this module, clients are requesting some services from the server, and servers are responding back with the services to the clients. Another interaction method at the application layer is the peer-to-peer module. In this module, a user client can be a client or also can be a server at the same time. The most popular peer-to-peer applications are the torrent applications. In this section, we are going to talk about the common network protocols that clients use while they request services from the servers. The first protocol we talk about is HTTP, which we use when we try to reach a web page mostly. HTTP is the underlying protocol used by the World Wide Web, and this protocol defines how messages are formatted and transmitted and what actions web servers and browsers should take in response to various commands. For example, when you enter a URL in your web browser, this actually sends an HTTP command to the web server directing it to fetch and transmit the requested web page. SMTP is a protocol used in sending and receiving email and uses port 25. However, since it is limited in its ability to queue messages at the receiving end, it is usually used with one of two other protocols, POP3 or IMAP, that let the user save messages in a server mailbox and download them periodically from the server. The POP protocol is used by local email clients to retrieve email from a remote server. POP works with Simple Mail Transfer (SMTP) protocol for end-to-end email communication, where POP pulls messages and SMTP pushes them to the server. IMAP is also used by local email clients to retrieve email messages from a remote server. IMAP can be contrasted with POP. With POP3, mail is saved for the end user in a single mailbox on the server and moved to the end user's device when the mail client opens. While POP3 can be thought as a store and forward service, IMAP can be thought as a remote file server. Original copies are stored in the mail server until it is deleted. And let's go ahead with the DNS, Domain Name System. DNS is used to convert a computer's host name into an IP address on the internet. For example, when you type www.google.com, There's a DNS server serving on the internet or in your local area network responding you that www.google.com's IP address is this one. So what you're exactly doing is going to this IP address. DNS uses a hierarchy to manage its distributed database system. The DNS hierarchy, also called the domain namespace, is an inverted tree structure much like a directory. The DNS tree has a single domain at the top of the structure called the root domain. A period or dot is designation for the root domain. Below the root domain are the top level domains that divide the DNS hierarchy into segments like .edu for educational organizations, .gov for government agencies, .com for commercial organizations, and etc. The next level in the DNS hierarchy is the second level domains. This is the domain that is directly below the TLD. This is the main part of the domain name. It can vary according to buyer. For example, contoso.com. The subdomain can be defined as the domain that is a part of the main domain. For example, example.contoso.com. You can configure the IP address of the network devices in two ways. The first way is static configuration. The second one is using DHCP. By using DHCP, you can assign IP address, subnet mask, gateway, DNS, and domain name to a networking device dynamically. If you're managing a small network, you can statically assign IP address configurations to your devices, but for big corporate networks, DHCP is almost mandatory. There's a process while a PC is demanding an IP address from a DHCP server called as the DORA process. The first step of the DORA process is DHCP discover message. In this message, this PC is saying that help, I don't have an IP address, for example. This is a broadcast message and searching for an IP address. When server gets this message, that responds with a DHCP offer unicast message and says that how about these addresses? I have an IP address for you. Do you want it or not? Okay, the client takes this message and say that can't I just use the address I had before, for example, or that can also accept the IP address that DHCP server offers. And this is the message saying that, for example, can't I just use the address I had before, or it's okay, I'm accepting your offer, is a DHCP request message and send broadcast again. Then the last step is the acknowledgement, and server responds back with an acknowledgement message again and says that fine, here it is. Okay, no problem. I'm assigning the IP that you want from me. And okay, this guy is saying last time, awesome, I'm somebody now. Another application layer protocol we are going to focus on lastly is the file transfer protocol. File transfer protocol is used to transfer computer files between a client and server on a network basically. This protocol uses port number 21.